Today we're going to be talking about molarity. So molarity sounds very similar to moles. They actually do have a lot to do with each other. Molarity is the concentration of a solution in moles per liter. So it's the amount of moles of material of a compound that is dissolved per liter of solution. The solution is usually, or the liquid that's doing the dissolving is usually water, but it doesn't have to be. And now we have some vocab to really make this work a little bit better. The solute is the thing that's being dissolved. So the solute is the stuff being dissolved. This could be salt in salt water, sugar in sugar water. It's usually a solid, but it doesn't have to be. The solvent is the thing doing the dissolving, usually water, but again, does not have to be. You can dissolve things in, you can dissolve solutes in other solvents than water, but water is the most common. Solution is the mixture of the solute and solvent mixed together. So the way you can tell if you're dealing with a true solution is you can pass light through it. Now, if it's a really dark solution, it won't let as much light through it, but light will still get through. As opposed to something that isn't a solution, like for example, if you just had muddy water, then the mud is a solid. It's not actually dissolved in the water. It's just kind of sitting there. That's going to block light from going through it, whereas a truly dissolved solution means there's no solid in that water. Everything that was a solid is being dissolved in the water. It just happens to be very dark, like this. So this would be a high molarity solution. If I was dissolving, blue stuff into my water, this would be like really dark blue, so dark blue that it would be hard to see through. But if I put a bright enough light on it, it will go through. And then a low molarity solution would be like faintly blue, like so barely blue I couldn't, notice it. And then obviously there's a whole bunch of degrees of how soluble or how concentrated something is. So what molarity really is just a numerical way of expressing how concentrated something is. So like if you make, let's say you made a sports drink mix, right? And it was super sweet. Well, that would be, we would call that highly concentrated or have a high molarity. So it's a number that represents exactly how concentrated a liquid is. In chemistry and in science, knowing how concentrated a solution is can be very important, especially in biology, but also in chemistry as well. Last thing we need to mention is the total volume is going to be the total volume after you add the solute, not before. And the reason is simple. If I were to, let's say, take a coffee cup and I fill it with coffee to the very, very, very tippy top of the coffee mug so that there's no more room for anything to fit into that coffee mug, and then I add my scoop of sugar, well, then it's going to overflow and I'm going to have wasted some solution, right? Some of the water will, or the coffee will have overflowed and I won't have an accurate number. So what you have to do is you put the thing that you're dissolving in first, and then you add the solvent, typically water, to the mixture, so that way you don't overfill and you get an accurate number. That's kind of more of like a thing that you would do if you do this in a lab. That's a technique that's really like a lab technique, but I did want to mention it here. So there's two formulas that often get used together, sometimes three. So not really, the third one's not really a formula, but we have the molarity formula, molarity equals moles over liters. And then we have the mole formula, moles equals grams over GFM. Turns out you can take the moles you get from a mole calculation and plug it into a molarity calculation, and vice versa. You could go in both directions with this. And often you see unit conversion mixed into these problems as well, mainly having to deal with the fact that the volume is in liters, but it doesn't have to be just that. It could also be the mass being in, for the mole formula has to be in grams, so they could give you a kilogram mass and ask you to convert it and things like that. So you could use King Henry there, and you could use King Henry over here sometimes, but that's pretty much it. So we have 3 practice problems. We're going to do them together, and then we'll move on to the work. So the first practice problem says a solution has a volume of 2 liters. So the way I like to write this out, big M is the units for molarity. The units for moles is actually MOLE. They're not very creative. All they did was drop the E off the end of the word. But, MO is an element and little m is taken by meters. So the next best option for an abbreviation or for a shortened unit is MOL. But so let's see. 2 liters of... The solution has a volume of 2 liters, so 2.0, and it contains 36 grams of glucose. Now, the reason I know I have to use both formulas here is because of units. It's always, unfortunately, the units. And the reason is simple. My 36 is in grams, and I know that this solution needs moles. But I also know that if I'm given grams and a formula, I can convert that into moles relatively easily. So my 36 grams goes there. The GFM of glucose, I'm not going to do it. We've done it a bunch of times. It's 180. And now I'm going to solve for moles. So I solve for moles and I get 0.2 moles of glucose. And then I plug that in over here. And I solve for my molarity and I get 0.1 molar is how it's said. Glucose. And I'm going to put AQ next to it to say that it was dissolved in water. Although, looking back at the question, they don't specifically mention water. So to be safe, okay, I'm not going to mention AQ because AQ implies dissolved in water, and I don't know if this was dissolved in water. You can dissolve sugar in alcohol too, and that's how they make sweet alcoholic drinks. You know, they dissolve sugar in alcohol too, so it doesn't have to be water. So I'm not going to put the AQ there since they didn't say it. Number 2. A solution has a volume of 250 milliliters and contains 0.7 moles of NaCl. What's the molarity? So they gave me 0.7 moles. They want molarity, and they gave me 250 milliliters, which when I use King Henry is 0.250 liters. That's where that came from. That's the M, and to go to liters, I move the decimal 3 to the left. So I get 0.250 liters. Divide the two numbers, and you end up getting 2.8 molar NaCl. Okay, last question. How many grams would that be? So this is like a 2-part question, but it doesn't have to be 2 parts. They could have just asked, instead of, they could have asked, what else? They could have just asked for the volume of, or the mass of the NaCl in the very first question, and you would have had to have done this first step first, and then use the mole formula to do the second half. I broke it into 2 steps just to make it a little bit easier, but these can be combined into one problem very easily. So we got 0.7 moles, and we have a GFM for NaCl, which is 58. You add it up, and then we want moles, cross multiply, or sorry, that's a mistake. It's grams over GFM. And then when we cross multiply, solve for x, we get so this is how you use the molarity equation, and as well as the mole equation, and they can be used together. They can be used separately. Like for example, in this first part of 2, I used the molarity formula separate. In the second part of 2, I used the mole formula separate from the first part, but it also could have been combined into one question. They just would have had to given you a molarity and then not included the mole number, and then you would have solved for moles and went into the mole equation. So it can be, you can use both of these equations both forwards and backwards, and you have to be able to do that.